Okay, in this video I'm going to continue an earlier video that I had done related to the use of beam elements in ProEngineer, ProMechanica Finite Elements. What I want to do is, though, in this one is further explore some issues with beam releases. So I'm going to go through some of the things that I did in the previous video incredibly fast, including creating some datum points that I'll use to support my beams. And I'll pick my coordinate system as a reference, and my first point will be at the origin, and my second point will travel along the x-axis a distance of 100 inches, and my next point will travel in the y-axis, or would be located in the y-axis, a distance of 100 inches, and I will have my 3 points, and I will say OK, and I have my point 0, my point 1 aligned with the x, and my point 2 here. Those are all the geometry that I need for creating the beams. And so before I go application mechanica, I know my units are going to be wrong, so I'm going to go edit setup units. Again, doing this very fast because you've seen it before. I'm going to change to inch pound seconds. I'm going to set it. I'm going to say OK, and I'm going to close it. And now my units are fine. I'll click done. I guess you couldn't see that. That's okay. You know how to do it. I'm going to go applications mechanica, and my units are now fine, so I'll say continue. I won't change anything here. It is going to be a 3D model composed of beams. I will say OK. And now I'm ready to start creating beams and materials and loads and constraints and all of those other kinds of things. So one of the first things I'm going to do is constrain point 2 and point 0 so that they can't move. So I'll pre-select. No, let's see. Let's see if I can do it this way. If I don't want to select them both. I want to select one at a time. I'm having trouble getting the point, but I've selected point 0, and I will go to the constraint. Everything's constrained. Okay, that's good. I'm going to go to point 2, see if I can get that. I'll right click and bring point 2 forward, select that, go to my constraints, everything's selected. Okay, those 2 points are constrained. Now I'm going to create my beam by clicking on beam, and I'm going to go with point-point pairs as I did last time. And I'm going to click on point 0, and then I'm going to control click on point 1 to add it to the list. I'll control click on it again, put it in the list again, and I'll control click on point 2. I now have 2 point-point pairs. My material, there is no material for the part, so I'm going to go more, and I will select aluminum. OK, OK. My beam is now made of aluminum. I now need to create the beam cross section. And so my beam cross section, there are none to pick, and I'll go with more, and there are none here, so I'll go with new, and I'm going to create a rectangular cross section of B of 4 and D of 2, and I will say OK on that, and I will say OK on that. And so beam section 1 is my beam cross section. I will accept those beams and say OK, and I can see those 2 beams have been placed into the model. I've got constraints, I've got beams. I'm going to place a load at points, point 1, and let's go down 100 in the y direction. So minus 100, and preview, and I like it. And that's fine. There's my load. Right now, I've got a cantilevered connection here, a cantilevered connection here, and a cantilevered connection between these 2. Now let's turn on some beam releases. And so I'm going to go to idealization, beams, and I'm going to go to beam 1. And for beam 1, I'm going to edit definition. Let's bring this in where you can see it a little bit better. And let's go to beam release. It says there are none, none exist. More, none exist. New. Beam release 1, I'm going to release the Z direction, which is releasing the local Z direction on a beam. Okay, by default everything was fixed. Anything I click will be unselected and therefore be able to move in that degree of freedom. So I'm going to give this beam, when I apply this beam release 1, whose name I'm going to change to Z release. Okay, Z release will release rotation about Z. Okay. Okay. And now I've got a Z release at the beginning of beam 1 and I'm going to choose a Z release at the end of beam 1, and I'm going to say OK, and then I'm going to go to beam 2, and I'm going to edit definition, and again bring this into the screen where it's easier to see. And for the start of this beam, I will turn on my same Z release, and at the other end of the beam I'll turn on my Z release. OK. I want to double check this one because I just don't quite remember what I did. Edit definition. At the start I've got a Z release, and at the end I've got a Z release. That's exactly what I wanted. Now if you look carefully, you can see that circle. That means a Z release on the red beam. If you see that little bitty circle right next to my mouse, that's a Z release on this beam at that end. And we'd have to clear out some junk maybe, but I can just barely see a little red circle above my mouse. See if I can zoom in a little better and find an orientation where I can see it. With the mouse down, I was able to see on that lower end of the red beam, I quite clearly see a circle there. As I rotate, let me see if I can bring it into view. Very hard to see. Okay, I begin to be able to see on the left hand end of that red beam a release circle. So I've got a release at both ends of those beams. Let's see what effect they have. I've got supports, I've got materials, I've got beams, I've got loads. I should have everything I need to run this, so I will go create a new analysis. File, new static. It'll call it analysis 1. Let's go ahead and converge to 1%. Let it go up to a maximum of 6. That's fine. I think it will converge. OK. Run. Yes. No. It's probably finished. Now it is finished. We will close it and go look at the results. And I'm most interested in the deformed shape for now. And no need to show the elements. OK, and show. Before I look at it too carefully, I want to view it square from the front. Okay, and here's what I see. If I see any curvature at all in these beams, then I know that one of my releases didn't work. This appears to be a cantilevered connection and a whole lot of curvature in that beam. I believe that release didn't work. I see this beam coming in asymptotically tangent to that blue line, meaning this was a cantilevered end as well, and this release didn't work. Hard to tell if this one worked, but these are both coming in as straight lines, so I believe that this one worked and that these two did not. Why not? I don't know. That just appears to be the nature of ProMechanical using beam releases, that the beam releases at the wall, quote wall, with no other beams there, don't work, and the beam release between these two beams did work. So I'm going to go turn off some of these releases. And again, going into idealizations and beam 1, I'm going to edit definition and turn off the release at the beginning of beam 1. Notice my beam 1 is selected and point 0 is red. That refers to the beginning. Point 1 is the end. So I'm going to turn off the Z release at the beginning, go to none, but I'm going to leave the Z release at the end. OK. And then I'm going to select, let's see if I can double click on this beam. It did. And the red one, point 1, is a Z release. And I'm going to turn it off. And then I'm going to go to the other end and turn it off as well because it was ineffective. This Z release and this Z release was ineffective. I only really need one of these two beams coming into this joint to have a Z release. And I've left the Z release on the lower beam. I've now removed all Z releases from the upper one. I'm still going to have a pin here because I only need one. I'm going to say OK. Now if I do nothing else, I'm going to get the exact same analysis that I had a moment ago. Cantilevered here, cantilevered here. One release is enough here. There'll be absolutely no difference in the results between these two runs. But I want to make it different because what I want to do is show you how to get the release effect at the wall. I need to edit the point. And in editing the point, I'll allow a Z rotation. OK. And I'm going to edit the displacement constraint I put on this point and allow a Z rotation of the point now. I'm going to say OK. And in this run, I've got non-cantilever. I've got a pin joint here in the Z direction, a pin joint here in the Z direction because of what I did to the point. And I've got a pin joint here in the Z direction because of what I did through the beam releases. I should get exactly what I'm after when I run this analysis. Yes, no, watch it happen. It's done after pass 2. Let's go see the results. And I want to see deformed. Okay, and show. Let's view it square before I pay any real attention to it. And I see that this beam is absolutely straight. I see that this beam is absolutely straight. And so I have a pin joint here because of the Z release on the bottom beam. I have a pin joint here because of what I did to the point constraint, and here what I did to the point constraint. I now have what I wanted to show earlier, but it didn't work precisely as I wanted it to, and I still don't understand why the Z release didn't work here or here, but I now know that that's just the way it is, and we have to live with it. And that's what I wanted to show you about beam releases. So that ends this video.